this video will be about a drone that I have been working on, and this is the drone. Now I am very excited to share with you guys this drone because I have been working on this drone for the past few months. I have designed everything myself. The body of the drone was designed on SolidWorks and was 3D printed on my own 3D printer, which you can see behind me there. And this 3D printer also I have made it myself, and I have shared with you how I have made this 3D printer on my previous videos. So if you have not yet watched those videos, make sure to check it, guys. And I yet have to finish that video series because my laptop was broken and all my files for that video was on my previous SSD storage. I have to recover it from this SSD storage, and I will finish that video series very soon, guys. So stay tuned for that also, guys. Now in this video I will be talking about this drone, and this is very important to me because lots of days, nights have gone for me to design this drone. And because this drone I have tried to make it as cost effective as possible. I have designed it in such a way, taking the engineering aspect for this drone, trying to reduce the weight as much as possible, trying to reduce the vibration caused by the motors, to translate from the motors to the main body to make the sensors to work more efficiently. And I have designed it in such a way that the battery fits perfectly in the middle of the drone, and the electronics are placed at the top and the bottom of the battery, which reduces the weight drastically, but also allows you to put all the required electronic parts in this drone. Now there are electronic parts at the top of the drone, and there are electronic parts at the bottom of the drone. Now this drone is fully based on the Arduino to reduce the price more, and also to increase your educational level about programming, control engineering, and everything about drone. Now I will not be talking about the engineering aspect of this drone. If you guys are interested in the engineering aspect of this drone, how I've designed it, what factors I have taken into consideration when designing the body of the drone, the control engineering, the propulsion engineering, and everything, let me know in the comment section. I will try to explain it to you to my best knowledge. But in this video I will be showing you how I have made this drone, how I have assembled it, and you will also find links where I have buy these components. And if you guys want to make this drone, you make sure to buy those components from the links that I will be sharing in the description below, or in my website, which you will also find the links in the description. And make sure to buy those components from the links that I have shared with you guys, because you will find the components at the lowest price, and you will get your components very soon. So make sure to check those links also, guys. And about the programming, the coding of the drone, you will also be finding it on my website. You will find the links in the description for this also, and for the STL files also. Now if you guys are watching this video during the release of this video, you will not find the STL files for the drone body on my website, because the design for the drone body also was on my previous SSD card, which I yet have to restore. But I will restore it very quickly and post this design also on my website. And you can 3D print the body for your own drone yourself if you have a 3D printer, or you can make your own 3D printer if you watch my previous video. Or if you have any 3D printing services, you can just drop the files there. They will 3D print it for you. And talking about the electronics that I have used in this project, now I have used the MPU 6050 gyro sensor to send feedback to the flight controller to maintain stability. And this is a very effective sensor, which is very cheap, and you get accurate values from this sensor. For the flight controller, the receiver and the transmitter, I have used the Arduino to reduce the price more. And the Arduino is very cheap, so I have made a transmitter for less than $10, which is very good. If you go into the market and search for commercial remote control, the transmitter, it is very expensive. You can get it for $50 to $200, which is expensive compared to the one that I have made. Now I have made a video how to make your own transmitter and receiver. I will be using that transmitter and receiver itself in this drone, and there will be link in the description where you can watch those videos, so make sure to watch those videos also in order to make this drone. Talking about the flight controller, the Arduino, I have uploaded the code in the Arduino, and I have used multi-Win GUI to configure my drone. Now I will also be sharing the links where you can download this interface so that you can configure your own drone. And I will go very quickly how I have assembled this drone. I will not go into detail about assembling this drone because it is very straightforward, and for the circuit and for the electrical connection also, you will find it in my website. I will not go through the soldering process, the connection process. You will find it on my website, so check this also. And for the programming also, it will be on my website. The files, the design files also will be on my website. Now previously I intended to use the Arduino Mega Pro Mini for this the flight controller of this drone, but I have tried this Arduino, and that's why I'm not able to implement the GPS also, because if I had the Arduino Pro Mini, I would have just to connect the GPS and it should work fine with the flight controller. But unfortunately the Arduino Mega Pro Mini was damaged, and I had to switch to Arduino Nano, but Arduino Nano does not have that much memory to handle the GPS also. So if I have to implement the GPS, I will have to add another Arduino Pro Mini and upload the I2C nav to the Arduino Pro Mini, then connect it to the Arduino flight controller using I2C protocols. But I do not have another Arduino. I have placed the order, but I have to wait for it. So in this video I will not be implementing the GPS. Now the GPS is used for position hold. You can make your drone stay at a fixed position, and you can also plan a path where your drone will go. Now the GPS is very interesting when implementing it in a drone, and also I have to use the MS5611 barometric sensor for altitude hold, so that your drone is at a fixed altitude. But I have ordered it, and it has not yet I have not yet received it, but as soon as I receive it, I will upgrade this drone to have a altitude hold and also a position hold, which will be for later videos, but I will keep you updated with the upgrade of this drone. And talking about the ESC, I am using a 20 amp ESC. It is a 4-in-1 ESC to reduce the size of the drone more. It is very compact, but I am using a 20 amp ESC for this motor because the maximum current draw by the motor is 15 amps, so I have taken a safety factor of more than 20% for the ESC. And talking about how I have configured this drone is using the multi-Win GUI. You can tune the PID values for the drone there. Now I will not go through the PID tuning values. Now if you guys are familiar with control engineering, you will know that the PID stands for proportional, integral and derivative, which is used in control systems. And you will also find the programming for the receiver and the transmitter in the description below or in my website, so make sure to check that also. And I hope you guys have liked this project and it was a successful project. Let's do a test about it to see how this drone is flying. So thank you guys for watching. I hope you have enjoyed this video, and if you want more project like this, make sure to like this video and subscribe to my channel. So see you later guys.